Before we look at an example, I'd like us to think about an algebraic property that's going to help us look at 0 times infinity indeterminate forms. So first, let's consider what a divided by b to the minus 1 means. Well, b to the minus 1 means a divided by 1 over b. And then when we're dividing by a fraction, or dividing by anything, that means multiplying by the reciprocal. So dividing by 1 over b is the same as multiplying by b over 1, the reciprocal of 1 over b. And of course, a times b over 1 is just ab. So in previous math classes, usually you're getting from something that looks complicated like this, and you're trying to simplify so that it looks nice, like a times b looks nicer than a over b to the minus 1, or a over 1 over b. But for our 0 times infinity indeterminate forms, we're going to go the other way. We're going to make it look a little uglier so that we can actually take the limit. And so if I have something like the limit as x goes to 0 from the right of the square root of x times the natural log of x. Square root of x looks like this, and natural log of x looks like this. And as I approach 0 from the right, this graph is going to 0, and this graph is going to minus infinity. So we have a 0 times infinity indeterminate form. I'm going to make this look a little bit uglier so that I can actually compute the limit. So I'm going to use, I started with a times b. But I'm going to rewrite it and move one of them to the denominator. It doesn't matter which one I move to the denominator. A times b is the same as b times a. So I can move whichever one I want to the denominator. It doesn't matter which one I call a and which one I call b. And so I'm going to move the square root of x to the denominator. I'm going to leave the natural log of x where it is. So natural log of x over square root of x is x to the 1/2. And then if I move it to the denominator, it now becomes x to the minus 1/2. And as x goes to 0 from the right, this is still minus infinity, same as it always was. X to the minus 1/2, that's 1 over the square root of x. As x gets very small, square root of x gets very small, but 1 over square root of x gets very large. So this is an indeterminate form of infinity over infinity, which is a little discouraging. We're trying to get away from indeterminate forms, but luckily, infinity over infinity is one of the indeterminate forms I can use L'Hopital's rule on directly. So if I try that, the derivative of natural log of x is 1 over x. The derivative of x to the minus 1/2 is minus 1/2 x to the minus 3/2. And then when I try to simplify, I have the limit as x goes to 0 from the right. 1 over 1/2, get a minus 2 in the numerator. And x to the minus 1 over x to the minus 3/2 is going to be an x to the positive 1/2. If I use the second law of exponents, I get x to the negative 1 minus 3/2. That's x to the positive 1/2. And so now, I try direct substitution. Minus 2 times the square root of 0 is 0. And that's my final answer. So to recap, what do I do with 0 times infinity indeterminate forms? I use this pretty simple algebraic identity. A times b is the same as a over b to the minus 1, or a over 1 over b. But I use that on my 0 quantity and my infinity quantity. I move one of them to the denominator. that will turn 0 times infinity to either infinity over infinity or 0 over 0. And those are things I can use L'Hopital's rule on. So it's really just one extra algebra step before we apply L'Hopital's rule.